Hello, this is going to be lesson 4.1b. We're going to be talking about adding fractions with unlike denominators. Okay, so the standards we're going to be working from today include I can add fractions with unlike denominators, I can add mixed numbers with unlike denominators, and I can reduce fractions to lowest terms. So let's get started here. And the standard is finding the greatest common factor of two whole numbers less than or equal to 100 and the least common multiple of two whole numbers less than or equal to 12, knowing that the greatest common factor and the least common multiple are what are used to find the common denominators. And then be able to use the distributive property to express the sum of two whole numbers 1 to 100 with a common factor. We've already kind of talked about the distributive properties, so we're mainly going to be focusing on the first greatest common factor and least common multiple in terms of fractions. I'm going to minimize myself and let's get started. So adding fractions with unlike denominators. Fractions can only be added together if they have the same denominator. Remember, the denominator is the bottom number of the fraction. So here is 1/7, and we're going to add 3/8 to it. We cannot add them the way that they are because the 7 and the 8 are different. We're not talking about equal-sized pieces. So we have to write an equivalent fraction where we have the same bottom number, the same denominator. So how do we do that? So here we are. They cannot be added because they have different denominators. So we need to rewrite them into an equivalent fraction. Notice that the word equivalent has the sound of the word equal. So we're going to rewrite it into a different fraction that is actually equal to the first fraction. It's just renaming it. It's calling it something different, but we're really not changing the proportion at all. So we need to use the least common multiple to find the common denominator. So 56, because the least common multiple of 7 and 8 is 56. Remember how you would count by 7s? Let me just type that in for a second. So you would count 7, 14, 21, 28, 35, 42, and 56. That's for 7s. And then for 8s, you do the same. 8, 16, 24, 32, 40, 48, 56. When you find a match, that is your least common multiple. So the first match we have there is 56. So that is where the 56's come from, right? And draw a line here that lets me. Yes. So right here is coming from 56 and 56. Okay, once we have that, now we have to say 8 times what gives me 56. See if my computer will do it. Yes. So starting at the top, 7 times what is 56? Well, 7 times 8 is 56, right? So there's how we got our 56. So we have to do the same thing to the top. So if I times by 8, get my spotlight here. If I times by 8 here, I have to times by 8 up here. So there's my times 8. And then 1 times 8 is equal to 8. So 1/7 is equal to 8/56. It's the same ratio, the same fraction, it's equivalent, it's just written differently. And then we do the same with the bottom. So 3/8 is 8 times what? Down here gives me 56. 8 times 7 gives me 56. So whatever I times the bottom by, I also times the top number by. So my 3 here is going to be times 7. So 3 times 7 is 21. I've just rewritten 3/8 as an equivalent fraction of 21 over 56. Now I have the same denominators, the same bottom number, so I can add the top numbers. Remember, never add the bottom numbers together. So I'm just going to add the 8 and the 21. So they are called the numerators. So 8 plus 21 is 29. The 56 just stays on the bottom. Do not add the denominators. So now we have our answer to 1/7 plus 3/8. It is 29 over 56. There is our answer. So we're going to do some more of these in practice, a little bit more. So fractions, remember, can only be added together if they have the same denominator. So this is 1/3 plus 2/15. Notice how the bottom numbers are not the same. Always check for that, so that if you see that they are not the same, you know you cannot just add them together. So we need to write an equivalent fraction for 1/3 and 2/15. We're going to do that using the least common multiple. So let's do that by listing the multiples of 3. So count by threes: 3, 6, 9, 12, 15, 18. I could go further, but I noticed that I'm probably not going to have to go any further. So now let's count by 15s. 15, 30. Oops, I can stop. Why can I stop? Because 15 is a match with 15. So my least common denominator, my least common multiple of the numbers, 3 and 15, is going to be 15. So that will become my bottom number. So there it is. The least common multiple of 3 and 15 is 15. Now I do what I would have done. I have to say, okay, 15, we'll do the top first. 3 times what gives me 15? Whatever that is, then I have to times the top by that same number. I'll clear that because I'm sure that I set it up so the computer would do that for us. So 3 times 5 equals 15, so I times the top number by 15, and I get 1 times 5 equals 5. So 1/3 is the same as 5/15. And then 2/15 I really don't have to do anything to because it's already in 15ths, isn't it? So I can just say I multiplied 15 on the bottom times 1, and then I multiplied the top number 2 times 1, and I got 2/15. So that one didn't change. So now I can add. I add just the top numbers, the numerators. 5 plus 2 is 7, and then I just keep the 15 a 15. 7/15 is my answer. Okay, okie dokie, good to go. Let's try again. Okay, we have 1/6 plus 3/8. Notice how the bottom numbers are different. So we are going to have to find the least common multiple of 6 and 8. So how do we do that? We find the least common multiple. So let's list them. Count by 6s. I tab here. Okay, count by 6s. 6, 12, 18, 24, 30. I don't know, I might have to go further, but we're going to find out. So now let's count by 8, see if we can get a match. 8, 16, 24. Oh, I can stop. I have a match. So I notice that I have 24 and 24, my first match. So my bottom number, my denominator, is going to be 24. That'll be my common denominator. So let's go ahead and put that in over there. The least common multiple of 24 is, of 6 and 8 is 24. So now I say 6 times what has given me 24? And then I'm going to multiply the top by that same number. So 6 times 4 is equal to 24. So I'm going to multiply the top number 1 times 4 as well to give me 4/24. So 1/6 is equivalent to 4/24. Do the same on the bottom. 8 times what gives me 24? 8 times 3. And so I times the top number by 3 as well. And I get 9. So now I have 4 24s plus 9 24s. Now that the bottom numbers are the same, I can add the numerators. 4 plus 9 is 13. The bottom number is 24. 13 24ths. Remember, do not add the denominators. It just stays a 24. There is my answer. Yay. Okay, you get to try this. And go ahead and give it a try. See you back in a moment. Welcome back. Let's continue where we left off, adding different steps in the process. Now we're adding fractions that turn into improper fractions. Remember, an improper fraction has a bigger top number than the bottom number. It's improper because you normally see fractions written differently. So notice that 30 is bigger than 6, so 30 over 6 is an improper fraction. So let's see what happens when we add and get an improper fraction as an answer. So this time we're going to add 4 ninths plus 7 eighths. Notice how the bottom numbers are different. So if fractions do not have the same denominator, each fraction must be rewritten into an equivalent fraction with the same denominator. How do I do that? I find the least common multiple of 9 and 8. So if I was to count by nines, I would get 9, 2 times 9 is 18, 3 times 9 is 27, 4 times 9 is 36, 5 times 9 is 45, 6 times 9 is 54, 7 times 9 is 63, 8 times 9 is 72, 9 times 9 is 81, and then 10 times 9 is 90. I probably don't have to go further than that, but if I did, I would just continue from there. So now let's do the 8s. 8 times 1 is 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40, 6 times 8 is 48, 7 times 8 is 56. Oh, do I have a match? Nope. 8 times 8 is 64. 9 times 8 is 72. There is my first match. So that tells me that the 72 is going to be my least common multiple, and it's going to be the bottom number for my denominators. So let's put 72 in there. And now we ask the question again, 9 times what gives me 72? Whatever that answer is, I have to times the top number by it. So let's let the slideshow do its thing. 9 times 8 gives me 72, so I times the top number by 8. 4 times 8 is 32. Do the same on the bottom. 8 times what gives me 72? Well, 9, right? 8 times 9 gives me 72. So I'm going to times 7 on here, times 9 as well. So 7 times 9 is 63. Now I can add. I have 32 72s and 63 72s. I only add the top numbers. So we add 3 plus 2 is going to give us 5, and 6 plus 3 is going to give us 9. 95 over 72. Remember, the bottom number stays a 72. Notice how I now have an improper fraction because 95 is bigger than 72. I can't leave my answer like that. So an improper fraction needs to be converted to a mixed number. How do I do that? Well, I take my fraction and I do a division. So I make my little division sign over there on the left. I put the top number on the inside, 95. I put the bottom number on the outside, 72, and then I divide. 172 will go into 95. If I was to try 2 of them, I would be way over, so it's only 1. 95 minus 72 is going to be 23, because 5 minus 2 is 3, and 9 minus 7 is 2. 72 won't go into 23, so then I'm going to take that 23, that's going to become the numerator of my fraction. So the bottom is going to stay, as always, a 72. So that is 95 over 72 rewritten as 1 and 23 72s. There is our answer. Just adding one additional step to what we've already learned. Let's see that done again. Okay, so this time we're going to add 9/10 plus 3/4. The bottom numbers are not the same, so we have to rewrite them to have the same bottom number before we can add them. So we need to find the least common multiple. The best way to do it, let's count by tens. 10, 20, 30, 40, 50. I'm going to stop there. Let's count by fours. 4, 8, 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40. Notice how 40 is our match. So 40 is going to be our new denominator. So let's put that in there. Oops, 20. Oops, what did I do wrong? 2 times 8 is 16. Yeah, it's not 20. That's a mistake. Okay, let's fix that. So this should be 40. So now all my numbers are going to be up. Actually, let's do it in black so that we can see this written the right way. This class makes mistakes. It happens, especially when you're doing lots and lots of math problems. Okay. Oh no, 20 would work. Why would 20 work? What did I do? 4, 8. Okay, if I figured out my error, let's clear this. Let's erase this. I was right to begin with. Okay, what's my error? See if you can figure it out. What did I do wrong down here? I didn't count by fours, really, did I? Well, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is not 24, correct? What is 4 times 3? There's my error. 12. And what's 4 times 4? 16. And what's 4 times 5? 20. There is our 20. So I found my error. It's good that it happens sometimes because you want to double check your work always. So 20, let me see if I can circle that. 20 is the least common multiple. Okay, so that's where the 20 comes from. And then I say 10 times what gives me 20? Well, 2. So I multiply the top number. 9 times 2 equals 18. I want to make sure that I press record. Yes, okay. And then on the bottom, 4 times what gives me 20? 4 times 5 gives me 20. So I times 3 times 5, that gives me 15. And now I add just the top numbers, 18 plus 15. So 8 plus 5 is going to be 13, carry the 1, so it should be 33 over what? Yes, over 20. Now, I'm going to clear all my drawings here. I have an improper fraction because 33 is bigger than 20. So I have to use my division skills, make a little division house. 33 goes on the inside and 20 goes on the outside. And now I divide. How many 20s go into 33? Well, just one without going over, right? If I put 2 20s, if I tried to put 2 up there, I would have 40, and that'd be over. So only one. So 20 times 1 is 20. 33 minus 20 is 13. What do I do with my remainder? Well, it becomes the numerator of my leftover fraction. And the bottom number stays a 20. So that is my answer, 1 and 13/20. Yay! Want to see that one more time? Let's try one more example here. Okay, 11/15 plus 4/5. The bottom numbers are not the same, so we need to find the least common multiple. This time I'm not going to make a mistake. So I'll count by 15s, 15, 30, 45, etc. Count by 5s, 5, 10, 15. There is my match. So my match is 15. That's the first number that matches together when I count by. So 15 will be my number. Okay, so on the top, I can just keep it 11 15ths. So it's already in 15ths, right? I'm just timesing by 1, not really changing the number. On the bottom, I say 5 times what equals 15? Well, 5 times 3 equals 15. So I times the top number by 3 and get 12. Now I can add the top numbers, the numerators. 11 plus 12 is 23. My bottom number stays 15. However, I now have an improper fraction because 23 is bigger than 15. So now I divide, put my little division sign there. What number goes on the inside? Yes, 23. What number goes on the outside? Yes, 15. Now how many 15s go into 23? Just 1, right? If I was to times 15 by 2, I would get 30, and then I would be over. So 15 times 1 is 15. Now I subtract 23 minus 15, and I get 8. The 8 becomes the numerator of my leftover fraction. The bottom stays a 15. So my final answer is 1 8/15. Lots of steps, but I think you guys will be fine with it. I've seen a few examples now. So now you get to try it, and we'll see you back in a moment. Okay, welcome back. Let's continue adding steps. So now we're going to have to reduce our improper fractions to lowest terms. So now we're going to add 6/8 plus 3/4. Again, the bottom numbers are different, so we have to make sure that we get the same bottom number. So how do we do that? Well, count by 8s. 8, 2 times 8 is 16, 3 times 8 is 24, 4 times 8 is 32, 5 times 8 is 40, and then let's count by 4s. 4, 2 times 4 is 8, 3 times 4 is 12, I'm going to do it right this time. 4 times 4 is 16, and 4 times 5 is 20, and 4 times 6 is 24, and there is my match. Notice how, let me just get a different color here. I don't want to change those. Anyways. So 24 is my least common multiple. No, 8 is. Notice, I just noticed that. Let's undo that. It's 8, isn't it? 8 comes first. 8's lower, so it's going to be 8. So we can leave 6/8 as 6/8. The bottom number, though, we're going to have to multiply by what? By 2, right? So 6/8 will stay 6/8. Just multiply by 1. Bottom number 4 times 2 is going to give me 8. So I'm going to times the top. 3 times 2 is equal to 6. So now I'm going to add 6/8 plus 6/8. Now that my denominators are the same, I'm just adding the numerators. 6 plus 6. Let's add the numerators. Now I get 12 over 8. So that's an improper fraction, correct? Not only is it an improper fraction, but it needs to be reduced to lowest terms. So let's do that first. You can do it second sometimes, or you can do it first. We're going to do it first. I'll show you the other way later. To put a fraction in lowest terms, divide the numerator and the denominator by their greatest common factor. So how do we find the greatest common factor? Well, we list all the factors of 12. 1 times 12 is 12. What else? 2 times 6 is 12. I'm trying to put them in order, that's why I'm separating them. And 3 times 4 is 12. And then we do the same with 8. 1 times 8 is 8. And then 2 times 4 is 8. and then we find the greatest common factor. So we know which ones are common. Change my color here. So 1s are common, 2s are common, and 4s are common. Be careful now, we're not doing the least common multiple, we're doing the greatest common factor. So which one's the biggest? 4 is the biggest. So we're going to divide the top and the bottom of 12/8 by 4 and reduce it. So let's do that. 12 divided by 4 on the top, 8 divided by 4 on the bottom. Notice you have to divide by the same number, since our greatest common factor is 4 for both. So 12 divided by 4 equals 3, and 8 divided by 4 equals 2. We still have an improper fraction, but we have an improper fraction in lowest terms. So now we need to reduce or change 3/2 into a mixed number. So here we go. We're going to divide. The 3 is going to go on the inside, top number on the inside. The 2 is going to go on the outside, bottom number on the outside. How many 2's go into 3? Well, just 1. And then we say 2 times 1 is 2. 3 minus 2 is 1. The remainder becomes the numerator of my fraction. The bottom just stays at 2. So the final answer to this problem is 1.5. That is the answer. So notice how we just added an additional step. So we started out the video with adding fractions that have unlike denominators. Then we added in the part that they could become an improper fraction when they're added. And now we're adding in the fact that they can become not only an improper fraction, but a fraction that needs to be reduced. So let's take a look at another one. 6/18 plus 34 36s. Okay, first thing we need to do is get the bottom numbers to be the same. So we're going to find our least common multiple. So 18, comma, I believe 36 would be next, because 18 times 2 is 36. And then 18 times 3, 54. And then let's do the same with the 36. Well, we notice something right away, don't we? The first number when you're counting by 36s is 36, and there's our first match, and that's exactly what we need. So we have our least common multiple here. Our LCM is going to be 36. It's our first match. That becomes our bottom number for our fraction. Okay, and then we have to say 18 times what gives you 36? Well, 18 times 2. So we times the top by 2. 6 times 2 is 12. And the bottom, I think I forgot to change this. This should be a 36. See, let's change that. This is 36. Okay, so that one just would stay 34 over 36. Just times it by 1. And then we add 12 plus 34. What do we get? 46 out over 36. Okay? Now, notice we have an improper fraction right here. And we can reduce it. So we're going to find the greatest common factor of 46 and 36. So let's see. Well, 1 times 46. I might have to make a little more space here. Actually, I'm going to use a different color. Let's see. So we have 1 times 46, comma, 2 times what? What's 46 divided by 2? 23. 3 doesn't work. Does 4 work? No. Does 5 work? No. Does 6 work? Nope. Does 7 work? No. Does 8 work? No. I think that's it. And then 36 is 1 times 36. 2 times, what did we decide? 18, right? And 3 will work. 3 times 12. And let's see if I can squeeze this in here. 4 times 9. And also, squeeze that in there. 6 times 6. So we got to squeeze a 6 in there as well. Okay, which ones are common to both? 1s are common. 2s are common. That's it, right? Nothing else is common. So 2 is the greatest common factor. So I am going to divide the top, 46, by 2. And I'm going to divide the bottom, 36, by 2. So let's divide by 2, the greatest common factor of both. And what do I get? 46 divided by 2 is 23, and 36 divided by 2 is 18. I now have an improper fraction in lowest terms. However, I need to change it into a mixed number. I can't leave it as an improper fraction. So I'm going to have to bring out my division house. What number goes on the inside? 23. Number goes on the outside, 18. How many 18s go into 23 without going over? Yes, just 1. So 1 times 18 is 18. Subtract 23 minus 18. That's 5. What do I do with the remainder? It becomes the top number of my fraction, my leftover fraction. The bottom stays an 18. So my final answer is 1 5/18. Getting the hang of this a little bit? Okay, good. 6/18 plus 34 over 36. Did we just do this one? We did. We just did this one. We did that one already. I just doubled it. I must have doubled the slide. So, well, is this different? Oh, it's different. It's different. Because the same bottom number, but we don't have 46 this time. So let me go backwards. Okay, I'm just going to go on to the next one because that was exactly the same. So I just paused the video for a second to see that it was exactly the same. So here we go. One more example to try. 2/3 plus 16 over 21. I have to find my least common multiple, so I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21. And then I'm going to count by 3s. Well, by 21s. 21, 42. I don't have to go any further. Why? Because I have my match, right? Which one is my least common multiple, my first match? 21. So that's going to be my bottom number. And then I have to tell myself 3 times what gives me 21? 3 times 7, I times the top by 7, 14 over 21. The bottom number, 16/21s, just says 16/21s. Then I add them together, 14 plus 16, only add the numerators. That would give me 30, and the bottom number stays at 21. That is an improper fraction. It's also an improper fraction that needs to be reduced. So I have to find the greatest common factor of 30 and 21. So let's count all the numbers that multiply together to give me 30. 1 times 30, 2 times 15, 3 times 10, 3 times 10, 4 doesn't work, 5 does, yeah, 5 works, 5 times 6, 5 times 6, I think that's it. 7, 8, 9, 10. We already have 10 there. So yes, and then all the factors that multiply together to give us 21. 1 times 21. 2 doesn't work. 3 doesn't. 3 works. 3 times 7 gives us 21. And I think that's it for 21. Put those together. So we have to find the common factors and find the greatest common factor. So we have 1's are the same, not that, circle. 1's are the same, 3's are the same, and that's it. So 3 is it. We're going to divide the top and the bottom by 3. So this is actually going to be showing you now the other method first. So what we normally would do, what I showed you before, is we're going to divide the top and the bottom by 3. Showing you how this is going to work a different way as well. 30 divided by 3 is equal to 10. 21 divided by 3 is equal to 7. And then I would divide 10 by 7. And that would go in there once. 10 minus 7 is 3. So 1 3/7 would be my answer using the method we've been learning. I'm going to show you the other method now. So I'm going to clear this. So what you could do is before you reduce it, you could divide. So I'm going to divide first and then reduce. Or you could reduce first and then divide. So that's the way we've been doing it. Now we're going to do the opposite. We're going to divide first. So 30 is going to go on the inside and 21 is going to go on the outside. How many 21s go into 30? Well, just 1. And then I say 1 times 21 is 21, and I subtract. 30 minus 21 is going to be 9. That 9 is my remainder. It becomes my numerator. My bottom number stays at 21. Okay, now you notice how when we're dividing using this method, we're going to have bigger numbers that we're dividing. So now notice that 9 21s can be reduced. How do I know that? Well, let's list all the factors of 9. 1 times 9 and 3 times 3. So that's all the factors of 9. What about all the factors of 21? We did that one before. 1 times 21 and 3 times 7. Okay, and then we find the greatest common factor. Well, it's going to be the same as it was. It's going to be a 3. So that means we're going to divide the top and the bottom of our fraction now by 3. So divide 9 divided by 3. I'm doing it down here, it looks like. And divide by 3, top and bottom. That gives me 3/7. So the final answer then is 1, don't forget about the 1 3/7. So that's what we got using the other method where we reduced first and then divided. You can also divide first and then reduce. So we'll get the same answer either way, 1 3/7. Okay, so just showing you there's another way of doing it. Okay, it's your turn. Give it a try. See you back in a moment. Okay, welcome back. So this has been a longer video, so if you need to take a break for a bit, go ahead and do that and then come back to watch the second half. Now we're going to be adding mixed numbers. Each time I add another step. So now we have a mixed number, 3 3/8. We're going to add 4 3/12. Notice how we have different bottom numbers. We have to get the same bottom number first. So here's our rules. Change the denominators to the least common multiple. Add the numerators. Reduce the fraction to lowest terms. So what is the least common multiple of 8 and 12? Well, we can list all of the count bys of 8, 8, 16, 24, And then with 12, it would be 12, 24. So notice our first match is 24. So 24 is going to be our least common multiple. And then we say 8 times what gives me 24? Well, times 3. So we times the top by 3 and get 9 24ths. Then we say 12 times what gives me 24? Well, times 2. So we times the 3 by a 2. And by the way, it's a good idea to write these here because it's really easy to mix this up, okay? You might be saying, oh, I multiplied by 3, so I'm going to multiply by 3 here, and that's wrong, right? So you want to just write your little numbers there. So 3 times 2 is 6. Now we add 9 plus 6. That gives us 15 24ths. Okay, now we're going to reduce the fraction to lowest terms. Notice how this is not an improper fraction. It is not. The top number is smaller than the bottom number. So we're not going to have to do that dividing. However, we do have to find the greatest common factor of 15 and 24. How do I do that? I list all the factors of 15. 1 times 15 and 3 times 5. All the factors of 24. 1 times 24. 2 times 12. And 3 times 8. And, 4 times 6. One more of them. 4 times 6. So now we find the greatest common factor. What's the greatest? We have 1s, we have 3s. Looks like it's going to be 3. 3 is the greatest. So we're going to divide the top, 15, by 3. We're going to divide the bottom, 24, by 3. So 15 divided by 3 and 24 divided by 3 is going to give us 5 on top and 8 on the bottom, 5/8. Now we are not finished because we cannot forget that we have to still add our whole numbers over here. That was just our fraction part. So now let's add 3 plus 4. That's 7. Now we combine the 7 and the fraction. Okay? 7 and 5/8 is my final answer. So extra steps added each time. Let's do this again to see how that works. Okay, this time we're going to add a mixed number, but the result is going to be an improper fraction. The last one did not have an improper fraction. So let's see what happens when this does happen. So we have 2 3/4 plus 1 4/16. Bottom numbers are different. We have to find the least common multiple. How do we do that? We count by 4s and we count by 16s. 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. 16s we count by 16. Well, we got 16 already have a match, so 16 will be our bottom number. So there's our steps. So we change the denominators to the least common multiple of 16. Then we say 4 times what gives me 16? 4 times 4. Multiply the top by 4. That gives me 12/16. The bottom is just going to stay 14/16. We're multiplying by 1. Add just the numerators. 12 plus 14. That gives me 26. My bottom number stays a 16. Now I can reduce to lowest terms. I have to reduce the top and the bottom by the greatest common factor. So I list all of the factors of 26. 1 times 26 and 2 times 13. Then I list all the factors of 16. 1 times 16, 2 times 8, and that's it. Oh no, 4 times 4, and just 4 times 4, so we'll list 4 once. Which one is the greatest common factor? Well, it looks like it would be a 2. So we're going to divide 26 by 2 and 16 by 2. So 26 divided by 2 and 16 divided by 2 is going to give us 13/8. Okay, we still have an improper fraction, so we're going to have to divide. So we set up our division, convert it to a mixed number. What goes on the inside? 13. What goes on the outside? 8. And now we divide. How many 8s go into 13? Well, just 1. 8 times 1 is 8. 13 minus 8 is 5. that 5 becomes the numerator of my fraction and the 8 stays the bottom number. We're not done yet. Why? Because we cannot forget about our whole numbers over here. And we have just made ourselves another whole number that has to be added with those two. So let's let the computer do that. Add the whole numbers. 2 plus 1 is 3. Add the 1. Add this whole number to your total. 3 plus 1, that's going to give you 4. And then the 5/8 is left over. So combine the whole number total with the reduced fraction. So we end up with 4 and 5/8. 4 and 5/8. Lots of steps involved. I would encourage you to go back and watch this in presentation mode and sharing the slides with you so that you can see the steps one at a time. Okay, you get to try a couple problems like this and I'll see you back in a moment. Okay, welcome back. We are on the last part, our focus on higher order thinking. Congratulate yourselves, give yourself a pat on the back for sticking with it. How can these fractions be subtracted? 5/7 minus 2/7. I bet, I'm going to come back on here. I bet you can come with the answer. 5/7 minus 2/7. Well, subtract only the numerators. Subtraction will be the focus of our next lesson. So that would have been 3/7. Okay, so your homework is on Google Classroom, and I will see you all next time. Bye.